Hello guys, let's go and look at this Gauteng paper, Euclidean geometry. That is question number 9 we're going to work with right now. We are given that they say in the diagram below, uh, BCF is a triangle, BCF is a triangle, BCF is a triangle. So they're talking about this one. Let me mark it. Let me use red. So BCF, here it is. They say BCF is a triangle. With points B, F, and C on the circumference. Okay, it's fine. Now, they say AQ and AR are tangents. AQ, which is this line, and AR, which is that line, are tangents. So one could even think of tan chord here. Tan chord as B1, that will be equals to C2, and this other one, C1, will be equals to B2, tan chord, all right? You think of tan chord here. And they say FE perpendicular to AB, we can see there, we've got 90 degrees there. And FG, perpendicular to BC. FG perpendicular to BC, 90 degrees there. And lastly, FD perpendicular to AC, 90 degrees there. Okay. Now we need to prove that triangle BEF, which is this triangle, we need to prove that this triangle here that triangle is similar to CGF. Okay, let me take this out. Okay. We need to prove that the two are similar. Okay, where can we start? We can start with B1 equals to C2. So question number 9. We can start here. B1 equals to C. Is B1 equals to C2 because of tan chord. concord. We can say G1 equals to 90 degrees because of angles on straight line. But we have E2, which is equals to 90, and reason here it's given. That will allow us to conclude that E2 equals to G1. Okay, and the last one now, B angle EFE equals to G angle FC, and here this will be third angle of a triangle, third angle of triangle. Okay, so with this I can now write that triangle BEF, surely it's similar to triangle CGF because of angle. Okay, that's what I can do. All right, that's for 3 marks. We're done. That's for 3 marks. Now the second question there, which I think I'll need a space for it, it's this one. Number 2, they say we need to prove that FG square equals to FE times FD. So my advice is that we need to firstly derive our proportion from what we have here. Okay, let's do so now. Let's do so. We've got BE over CG equals to FE over FG, which at last you'll say FB over FC. This, we derive this because of similar triangles. So I'll take this down there and see what I can do from this. So let me for now, let me have that for now and see what I can do. So I've got FG, I've got FE and FG there, which is this one here, which is that one there. But let me see here. FG is also okay. FD, so I need to work this with this triangle, and also let me check. Why should I work with that? Because I'm looking for FD, so I need to work with that triangle, and also what? Let me see, and also this one, so that I can work with the last two. Right? This is a smartness question. So what can I deduce here? What can I deduce here? I understand this D2 will be equals to E2. That's what I understand there. And we've just proven. What have we proven? Oh, I've just proven that this equals to that. Let me check. BFE and GFC. Will that help me? Will that help me? I don't think so. So how about I prove the similar of this triangle? If I prove the similar triangles there, let me see what will that help me. Okay. I need black here, so I can say in triangle FDC and triangle FGB, what will happen? What will happen? Let's see. C1 equals to B2 because of turn chord. And D2 should be equals to G2. These are given to be 90. And the third one will be D angle F C equals to G angle F B as being third angle of triangle. What am I going to do here? This is what we're going to have. Triangle C D F similar to triangle B G F because of angle. Now, from here, let's derive the proportion as well here. We've got CD over BG, which is equals to FT over FG, and lastly FC to be equals to FG. Lastly, FC, okay, let me correct myself. CD over BG equals to FD over FG. And lastly, CF over B over FB. These are similar triangles. So we've got this. What can we do from there? What can we do? I think we can make we've got this one here. We've got this one there. And taking them, I think we can make FB subject of the formula. FB subject of the formula. FB subject of the formula. Let me take them. The first one, I would like to copy it. Let me have it down here. And copy this as well. Let me have it here. So let me make FC subject of the formula to both ratios. So here will be FE FC equals to FB FG. FC will be FB multiplied by FG all over FE. And what about there? You're going to have FD FB equals to FC. Okay, let me start with FC as well. Let me start with this one. I'll say FC, FG equals to FD and FB. Let me also make FC subject of the formula. That will be FD, FB over FG. This is equation 1. This is equation 2. Then let me equate the 2 as being 1 equals to 2. So what I have is FB. What I have is FB multiplied by FG all over FE equals to FD multiplied by FB over FG. I can say I can cross multiply here. Let me cross multiply. I'm going to have FB FG square equals to FD FB multiplied by FE. So I will need to take out FB, cancel FB both sides, and therefore finally FG square equals to FE multiplied by FD. And that's what we were looking for 6 marks. Guys, this wasn't easy. This wasn't easy. Please make sure you watch this from where I started. Make sure you understand, and don't forget to subscribe, like the video, and also share amongst your friends. Make sure you watch this from the beginning, guys. Make sure, guys. Until we meet again next time, love you all there. Bye.